So this is the lecture series on digital image processing. So we are discussing about image compression techniques from the last two lectures. So let's start today's lecture. So you see this diagram. This is a typical image compression model. FXY or say FXYT, then mapper. This is known as encoder. Okay, overall this thing is known as encoder. So mapper, quantizer, and then symbol coder. This is overall our encoder, and this is for compressed data for storage and information. Then as their encoder is there, so we need a decoder. So symbol decoder, inverse mapper. Then this is the compressed image, that is fdash xy or fdash xyt. Okay, this diagram is very important. If question comes like that, describe an image compression model, then you need to draw this. So very simple one: fxy or fxyt, mapper, quantizer, symbol coder, that is the encoder portion, then compress data for storage and information. So we need a decoder. So the symbol decoder, inverse mapper, and that is the our compressed version of the image. Okay, so today I am going to discuss some important image compression techniques. They are very important. The first one is what? Huffman coding. So first questions may come that what do you understand by Huffman coding? The or write the steps involved in. So Huffman coding is one of the most popular techniques for removing code redundancies. See, this is the means table. You need to draw this table: original source and source reduction, symbols, probability. A2 of arising of A2, the probability is 0.4, arising of A6, probability is 0.3. Similarly, for A1 is 0.1, A4 is 0.1, A3 is 0.06, and 0.04 for A5. So in the next step, so we are means going through one, two, three, four different steps. So overall, in the next step, you have seen that 0.06 and 0.04, that's being 0.1. Okay, at the first stage. Then the second stage, 0.1, 0.2, that becomes 0.2. Okay, second stage. Then 0.2, 0.1, that becomes 0.3 at third stage. So 0.3, 0.3, that is becoming 0.6 at the fourth stage. Okay, so that's how the compression or redundancy is being reduced. Okay, so now consider this diagram also. So now I'm coming from reduction to that again original source. You see that the fourth step of source reduction, we have 0.6 and 0.4. So that is becoming what? 0.01. Now then 0.4, 0.3, 0.3, then this is coming to 0.10, means 0.10, you know, if you represent it in the uh, the binary form, you know that 0 1 0 representing 2 and then 0 1 1 is 3. So then again this is coming to this one. So that's the way we are again coming from the reduced state to the original one. Okay, so take a screenshot of this and try to analyze this. That is how the Huffman coding works. Okay, Huffman code assignment procedure. That is very simple. Okay, code is very simple. You already got it. So you just need to have a binary means transformation understandings, and that's it. Okay, so that is our Huffman coding. Then we have arithmetic coding also. Arithmetic coding means what? Generates non-block codes, and it is used to remove coding redundancy. And one-to-one correspondence between source symbols and code words does not exist here. Okay, entire sequence of source symbols is assigned to a single arithmetic code word. Now, number of symbols in the message increases, then the interval used to represent it becomes smaller, and the number of units required to represent the interval becomes what? Larger. So that is our arithmetic coding. You can have a screenshot of this particular table. So we have source symbol, then we have probability, then initial sub interval. So you see that A1, A2, A3, A4 respective probability 0.2, 0.2, 0.4, 0.2. So that is 0. The sub interval is being this one. So one side closed and other side open. Okay. So arithmetic coding example is this one, and that's how the encoding sequence is going on. I am more focused towards this one after that means Huffman coding. So that is LZW coding. Okay. So after Huffman coding, I am focusing on this one LZW coding. Okay. So this coding technique addresses spatial redundancies in an image, and this technique is called Lempel-Ziv-Walz coding, and it assigns fixed length code words to variable length sequence of source symbols. And here main thing is that we don't need probabilities, and it was protected under a United States patent, that is LZW compression, has been integrated into a variety of mainstream emerging file formats like ZIF, TIFF, PDF, etc. And the PNG format was created to get around LZW licensing requirements. So after Huffman coding, the next important coding technique is our LZW coding technique. So guys, this is very important for you. Okay, so you see this example. So what you are actually looking at this image is that you see 4 rows and 4 columns. So 39, 39, 39, 39. This is being repeated, and the second column also, then 126 repeated in third and fourth column. So you see, I am using dictionary term here. So LZW coding is sometimes also dictionary, known as dictionary based coding. So dictionary location and entry. So 0, 0. See, similarly, for some means location, we have some entry. Okay. So you see currently recognized sequence, then pixel being processed, encoded output, dictionary location, then dictionary entry. So wherever you will find some similar information being repeated, just like 39, 39 repeated, isn't it? So you will find an entry for that in that dictionary. Okay. So that's why, I mean, so similar entries will have similar types of dictionary entries. So that's how the LZW coding works. Okay, so repeated sequences will be given similar entry to the dictionary. So that is LZW coding, but I have one assignment for you guys. So what you do, try to write the steps involved in Huffman coding and LZW coding, okay, and comment the answer. Okay, clear? So I need what? The Huffman coding techniques and LZW coding techniques steps. Okay, you will write them through comments, and I will wait for that. Okay, guys, that's all for today. Take care. Bye bye.